Hello and welcome back. In the last few videos we talked about how to use the factored form of a quadratic equation to graph a parabola. We established that in order to get to factored form we had to use the factoring methods that we had discussed previously. So the factoring methods for factoring simple trinomials and complex trinomials and applying difference of squares. So the truth is that we will not always be able to apply those methods because the roots will not always be whole numbers or simple fractions. So let us consider this example over here, negative 2x squared plus 4x plus 3. So that is a quadratic equation, and we're going to try to factor this using decomposition, the way we normally would. So we would multiply the first number by the third number, or negative 2 by 3 to get negative 6. And then we would recognize that we need two numbers that add up to 4 and multiply to negative 6. So we can try 1 and 3. And we can try 2 and 2. So 1 plus 3 is equal to 4, and 2 plus 2 is also equal to 4. We can then multiply each of these pairs of numbers. So we can do 1 times 3 is equal to 3, and 2 times 2 is equal to 4. And we'll notice that none of those numbers multiply to negative 6, so it's not clear the numbers that we're looking for. So whenever this happens, whenever we can't find the numbers that satisfy the two conditions required for decomposition in this case, we need to apply the quadratic formula, because it is basically telling us that the numbers that add up to the second number and multiply to that negative 6 in this case are hard to determine on your own. They are complicated decimals or fractions. So I'm going to begin by stating the quadratic formula. So for the general equation, or standard form, of a quadratic equation, which is ax squared plus bx plus c, we have that the roots or solutions of the quadratic equation, in other words the x-intercepts or the points that are on the x-axis for the parabola, are given by negative b plus minus the square root of b squared minus 4ac divided by 2a. So I will add some color coding if it helps to better visualize it. So we can see how we're plugging in or substituting the coefficients from the quadratic equation into the quadratic formula. So going back to our previous example, negative 2x squared plus 4x plus 3, we can see that a is equal to negative 2, b is equal to 4, and c is equal to 3. So if we have our quadratic formula, we can plug these coefficients into the quadratic formula, and we'll end up having that x is equal to negative 4 plus minus the square root of 4 squared minus 4 times negative 2 times 3 divided by 2 times negative 2. Once we plug in the values, all we really have to do is evaluate the expression. So we can see that 4 squared is 16, and negative 4 times negative 2 times 3 is plus 24. So in the root we have 16 plus 24. And we can also see that 2 times negative 2 is negative 4. So in the denominator we have negative 4. And then we have 16 plus 24 is equal to 40. So we have that the number in the root is 40, and we're left with negative 4 plus minus the square root of 40 divided by negative 4. So I'm going to rewrite that last line again over here. And the next question you might have is, what does that plus minus symbol mean? Well, it basically means that we have to both add and subtract. So our values for x from this equation are negative 4 plus the square root of 40 divided by negative 4, and negative 4 minus the square root of 40 divided by negative 4. So we do both the plus and the minus, and as a result we have two different values of x, because you would normally expect to have two different roots. And simply plugging these values into your calculator will give you that negative 4 plus the square root of 40 divided by negative 4 is negative 0.58, and negative 4 minus the square root of 40 divided by negative 4 is 2.58. So those are the two values of x that we need. Those are the two values of x where y is equal to 0, or where we have our x-intercepts, or roots, or solutions. And once again we established that the x-intercepts are at x is equal to negative 0.58 and x is equal to 2.58. We can then plot both of those points onto the graph. So once again, the first intercept is negative 0.580, and the second intercept is 2.580. And once you have those, you can determine the vertex by finding the midpoint and plugging that value in. If you do that, you will find that the vertex is given by 1, 5, and then you can connect the points to form a parabola. So the main purpose of the quadratic formula is to find the x-intercepts of the parabola when you can't find them using normal factoring methods. Normally you would prefer to use the factoring methods because they're simpler, but if the x-intercepts are crazy decimals that are hard to guess on your own, then you are much better off using the quadratic formula. So that is all I wanted to go over for this video. In the next video, we'll talk about the discriminant, which will allow us to determine the number of x-intercepts that a parabola has. But for now, as always, thanks for watching.